All right, my friends. So if you weren't sure how to go about this one, then I'll just kind of lead you through some thinking that you may find helpful. So what did they do to get from 5 to 15? Well, they could have added 10, but since they did not add 10 to 15 to get 45, we'll have to come up with another idea. So if addition doesn't work, then let's try multiplication. So what would you multiply 5 by to get 15? You could multiply 5 by 3. So you could think of 15 as 5 times 3, and then they're doing the same thing to jump from 15 to 45. So while this sequence is not arithmetic, it is considered geometric because instead of adding the same constant value every time, they're multiplying by the same constant value every time. So we'll talk, this whole section is about studying geometric sequences and series. So knowing that definition would be pretty handy. So we'll come back to that in just a second. So for now, let's talk about, what are they doing to get to the nth term? That you could just look at it and know, or you could do a t-table. I'll show both. So to get from the 5 here, the first term, to the 15, they had multiplied 5 by 3 once. And then to get from the 5 to the 45, they had multiplied that initial condition or initial value there. They had multiplied that by 3 twice. And so a pattern starts emerging that really you're just taking your first term, which in this case is 5, and multiplying it by that what we call a common ratio, which this time is 3, a certain number of times. And to get to the second term here, which is 15, you had a power of 1. And to get to the third term, which is 45, you had a power of 2. So, you could kind of think about, well, how about to get to any nth term? What would the power be? And so if that makes sense, then you could just jump to saying the nth term would be 5 times 3 to the n minus 1. That would be one way to go about it. Now, if that is too cluttery and messy for you at this time, and you prefer a little more order, then a t-table could tell the same story, just with a little bit more, let's see, pattern. There we go. That's not how you spell pattern. All right, pattern. Anyway, you could do a t-table to tell the same story. So if your first term is, or if you're on your first term, then your value is 5. Your second term, your value was 15, which 15 was 5 times 3. Your third term was 45, which was 5 times 3 twice. Your fourth term would have been 5 times 3 cubed. And some people really prefer this. You could put a 1 there. You could put a 3 to the 0 power there. And so you could kind of see that really what's happening, you pay attention to the parts that stay the same, pay attention to the parts that are changing, compare the number of term to the parts that are changing, and then you could jump to saying that, hey, look, here's the pattern or here's the trick for any nth term. You're taking your initial value of 5, multiplying it by your common ratio, that many times, and then it could lead you to this answer here. So hopefully that makes sense one way or another. Okay, let's summarize what we've talked about so far. So I've actually thrown a couple definitions at you already, so let's just make it official here. So first of all, how can we tell when a sequence is geometric? And it matters because there are certain tricks you can use when a sequence is geometric, but you wouldn't want to use it if you're not dealing with a geometric series. So let's kind of make sure you can recognize those. So a sequence is geometric if, and this is not textbook at all, but it serves my purposes a little better than the one in the textbook. So if there is a common, or let's say a constant value that is being multiplied, and actually, you know what? Let's slow down a little. That constant value that's being multiplied to each term to get the next consecutive term. In this context, it's called a common ratio. And you'll notice that they tend to use a lowercase r for it. So, okay, so let's back up. geometric if there's a constant value called the common ratio R being multiplied by each term to get the next consecutive term. So that's how you can tell you're dealing with a geometric. Okay, so we'll put a little cloud of importance around that one. Okay, so let's move to example 1 here. Okay. So for example 1, it says determine whether each sequence is geometric. If it is, state its common ratio. Okay, so see how it goes. Check in with me in the next video.